Yes. So here we need to configure a static routing so that when these user will send any traffic in this network, traffic will must go via R3, and when these user will send any data to this network, traffic will must go via this link via R4. So whenever this machine will ping to this machine R4, so whenever this machine will ping this machine, right, whenever 10.1 will ping to 20.1, right, your traffic, your request will must go via R3, and when this machine will generate reply, that reply will must go via this path, right. So this is just load balancing in a static routing, right, how you can perform load balancing, right. Means all request will go via R3 and reply will come via R4. So both link will use, both path will use, right. But how I will configure, what command I will run on R1? IP root up.
Hello.
Yes.
Sorry for late.
Okay, no problem, dear. We had just started. Firaz.
Hello.
Yes. What will be the command I will run on R1 to perform routing for
IP route?
IP route?
Yes, what do you want? Destination?
Destination is 192.168.20.0 255.255.255.0. Okay. And what will be the exit interface? What will be the exit interface? This one or this one?
192.
This one? Firaz, this one.
Maybe, yes.
Yes, definitely. If exit interface will be this one, then only this router will forward traffic to R3,
Yes.
right?
Yes.
So this is my task.
You can,
Yes.
but you can make a lot of scenarios here. For example, I can take it up 10, for example. I
Oh,
don't want to take it up 01. I want to take it up 10. Down.
okay.
Yes.
So that time exit interface will be this one.
Yeah, no, I'm talking in general. I can make different scenarios.
Okay. Okay.
Now but you will take it from upside, up 01. Yes, no problem.
So exit interface will be 0 by 1.
Yeah.
Right. What command I will run on R2? IP root on R3. IP root.
Yes. 192.168.20.0/24.
Okay. And exit interface F01. Okay. And for this network we need to configure routing on R3 for this network for 10.0.
192.168.10.0/24.
Yes.
Yes. Look, I found something also. For example, you can ping. I'm trying to use it. For example, from R3, I can ping any network from there. I can see if there is a ping or no. If there is a ping, I continue. No ping, I put the route. What do you think about?
Yes, sorry, I didn't get your question. Can you explain again, dear?
No. When I was
He's saying like he
doing
tried to ping
revision.
from PC1.
From
First
Yes,
he will try
right,
to ping
right.
the router 2.
Yes.
If he gets pinged, it is okay. And try to ping
Yes,
router
yes.
3. If ping, then okay. If not, then he will add a static route.
okay, exactly.
So step by step. He's saying that we will ping the next network that is pinging. Fine. If not, then we will add the static route.
Okay, but when you will ping this IP address or this IP address. Okay, yes, you can do in that way as well, in this way as well, right? You can configure in your way as well. Okay, you can. First you will ping your default gateway, right? If you are able to ping default gateway, fine. Then you will ping
Yes.
this IP address,
Yes.
right, from this PC or from R1, right? Then you will perform routing, but you will never ping this network or this network from here. If you will perform a static routing, right, this user can never ping this IP address, sorry, this IP address or this IP address, but they can ping this network, user of this from this network, right? So on R3 exit interface will be this one, right? So R3 will forward to R2 whenever R3 will receive a traffic where they will find destination IP address is 192.168.20.0, right? And now what command I will run on R2? IP route 192.168.10.0/24 at exit interface will be this one, right? So when this machine will generate reply, source will be 20.1 and destination will be 10.1. Now when this router will receive this packet, router will check their routing table for 10 network, right? Exit interface will be this one. So router will forward to R4. Now in the routing table of R1 you have to inject this network, right? And next hop will be,
So we are doing load balancing on the basis of exit interface, right?
yes. And you can configure exit interface and next hop IP address as well, both. You can configure both as well, right? I am only configuring by you exit interface so that it's easy to configure, right? Don't need to put next hop IP address again and again. That's the reason, right? You need to understand the logic. You should know the logic, right? How you will perform this thing, that whenever this machine will generate any request, that request bit must go via R3, and when this machine will generate reply will must go via this path. Okay, guys, need to configure or not? Should I configure this topology? Tell me.
Which one? Which one?
This topology, I will configure this here static routing, so that when this machine will generate any request, ICMP request, that request will move via R3, and when this machine will generate reply, that reply will go via R4. I can show you. But if you think that no, I can configure it, then I don't need to configure it here, right? So please let me know, should I configure?
Yes, please. Yeah.
Okay, fine. So first of all, let me configure IP.
Powerful.
Yes,
Powerful. I have something.
okay.
I was trying to use GNS3. I don't like it, but I was trying to use it.
Okay.
I want to add a router. I cannot find router. They are
You need to add images, iOS images. Have you added iOS image in GNS3?
If you go to edit, then preference, select new
After class I will do.
iOS update.
okay, no problem.
I also face the same issue, but Google has been
Yes. Yes.
I think even G is much more useful.
Yes, EvenG is more useful. I have EvenG also. I will show you how to download EvenG as well, okay? But now GNS3 is enough. For routing, GNS3 is enough. When we will create tunnel, when we will discuss VPN, then I will show you how to download, how to set up EvenG in your laptop, okay?
Okay.
Okay, thank you.
But now GNS3 is fine. So first of all, let me configure IP on PC1. So here I am going to configure 10.1 on this PC, right? And here I will configure IP 10.100. So 10.100 will become,
DNS3 also you need it to add module in router in order to make.
yes, you have option, you can add. Like now my link is fast Ethernet, right? And I want to add serial link. I can do that. I can add module. If I want more fast Ethernet, I can add module. Okay. So first of all, let me configure IP on this PC. Configure terminal interface fast Ethernet 0/0. I will configure 10.100 on fast Ethernet 0/0. This is my LAN interface, right? First thing is no shutdown, and IP address is 192.168.10.100. Subnet mask will be 255.255.255.0. Exit. Interface fast Ethernet 0/1. No shutdown, and IP address is 10.1.1.1. Subnet mask is 255.255.255.252. Because I am using /30, right? So 1.0 is different network, 1.4 is different, 1.8 is different, and 1.12 is different, right?
Yes, right. No problem.
Okay, so let me configure IP on fast Ethernet 1/0. Interface for fast Ethernet 1/0, no shutdown. IP address will be 10.1.1.9.255.255.255.252. Fine.
Yes.
Let me verify it. So IP interface brief exclude unassigned. This command will filter unassigned interface, right? They will show you only assigned interface, right? So you can see on fast Ethernet 0/0 IP address is 192.168.10.100, right? And status is up, and line protocol is up. Fine.
Yes. And packet with the 6.
Now let me configure R3, this router. Configuration terminal interface fast Ethernet 0/0, no shutdown, and IP address will be 10.1.1.2, 255.255.255.252. Exit. Interface fast Ethernet 0/1, no shutdown. IP address will be 10.1.1.5.255.255.252. Yes or no? Yes.
You are separating. Why you don't directly enter the IP route? Directly enter it, no problem.
Now I am configuring IP address. on interface only. Now I am not performing routing. Okay. On this interface on fast Ethernet 0/0, you can say I had configured this IP address 10.2, because on router 1 fast Ethernet 0/1 I had configured 10.1. Okay, let me verify it. So IP interface brief, yes. Now let me configure R2. Interface fast Ethernet 0/0, no shutdown, and fast Ethernet 0/0 is my LAN interface. So here I will configure 192.168.20.100. Subnet mask will be 255.255.255.0. Exit. Now interface fast Ethernet 0/1, no shutdown. IP address will be 10.1.1.6. Am I right?
You have one more dot.
Yes. Right. Now interface fast Ethernet 1/0. What IP address I will configure here? No shutdown. IP address 10.1.1. Suppose 14. 255.255.255.252. I will configure 13. Yes. Interface fast Ethernet 0/1. 0/0. See, on fast Ethernet 1/0 on this interface, which is connected with R4. Here I am going to configure 14, and on R4 I will configure 13, right? And 12 is network ID.
Yes.
Okay.
Okay.
So IP interface brief exclude unassign. See, on fast Ethernet 0/0 20.100, on 0/1 10.1.1.6, on 1/0 10.1.1.1.14. So I will configure 13 on R4. Configuration terminal interface fast Ethernet 0/0, no shutdown. IP address will be on 0/0 10.1.1.13 255.255.255.255. Right or wrong? Right?
Right, yes.
Okay. R4. Let me configure on fast Ethernet 0/1.
01.
IP address will be 10.1.1.9 or 10. 255.255.255.252. Let me ping my neighbor first. Ping 10.1.1.9. Yes, I am able to ping R1. Let me ping my another neighbor 10.1.1.14. Yes, I am reachable. Let me check from R2 to R3. Ping 10.1.1.5. Yes, let me check on R3. Ping 10.1.1.1. Yes, so R3 is also able to ping R1, right? Now let me configure IP on this PC. here on this PC IP will be 192.168.10.1/24 and default gateway will be 192.168.10.100. In the same way, let me configure IP on PC5. IP 192.168.20.1/24 and default gateway will be 192.168.20.100. Fine. Let me check, am I able to ping my default gateway or not? 192.168.10.100. Yes or no? No. Destination host unreachable. Why? I am not able to ping.
You are trying to ping from PC5, not PC3.
From PC5.
And you are pinging 10.100. It is a different network today. You need to ping 20.100.
Yes, I am pinging from this PC to this default gateway.
10.100 instead of 20.100.
This one is. No, I am trying to ping this IP address from this PC.
You have typed incorrect IP. 10.100 you are pinging. You are pinging 10.100.
Okay.
20.100.
So yes. Right, in the same way, let me ping from PC3 to default gateway 192.168.10.100. So yes, but I am not able to ping 20.1. Ping 192.168.20.1. I am not able to ping. Where my traffic is dropping? On which device my traffic is dropping, dear? On this device, on this device, on which device?
10.1.1.4 between R3 R2.
Between R3 and R2. Either traffic will drop on R2 or on R3, right? If traffic will drop on the link, right? So reason will be congestion.
Yes, in R3 it is dropping. R3.
Why not on R1? What will be the source? The source will be 10.1, destination will be 20.1. Router will check their routing table. In their routing table, they will not find entry, right? So how R1 will forward to R3? R1 will drop that packet on itself. Okay. So we need to perform routing. So first of all, let me configure R1. What command will be there on R1? IP route.
IP route
Okay.
192.
Okay.
168.
Okay. 20.0.
255.255.255.0.
Okay.
F01.
And next stop IP address.
10.1.1.2.
Anything else we need to configure on R1? No. Right? Now let me configure R3. So here we need to run IP route.
We only configure land side IP address, right?
Yes.
IP route.
So IP interface brief.
Hello. هلا عليك.
See,
ايه بس ال 3G القديم.
on all interface I have configured IP address. Okay, Govind?
لا ما عادش في.
And I have inject one route in the routing table of R3. So IP root, you can see static root S static 192.168.20.0/24 via 10.2 and exit interface is fast Ethernet 0/1. Fine. Now on R3 IP root 192.168.10.0 or 20.0.
10.0.
Oh, why?
Because 20.0 is already known to it.
How this router will receive a traffic for this network?
Configuring on router 3,
Yes.
I thought you were configuring router 2.
No. 20.0 mask will be 255.255.255.0 and exit interface will be fast Ethernet 0/1. Right. Now let me configure R2. Configure terminal interface fast Ethernet 0/, oh my god, IP root na, IP root which network? 192.168.10.0, right? And what will be the exit interface? Fast Ethernet
1/0.
1/0.
If you type subnet mask root 255.255.255.255.
Fast Ethernet 1/0, right? Now see what will happen if I will ping now. You can see same ping, right? 192.168.20.1. Request timeout. Still, now where traffic is dropping? Now on which router traffic is dropping? Okay, which type of on router 4? Which type of traffic is dropping? Request or reply?
Reply.
Reply, right? So now reply is dropping on R4. Yes, you are very clear with routing, Gobind. So on R4 configuration terminal IP root 192.168.
68.10.0 255.255.255.0 mask subnet 0/1.
Okay. PC3. Now let me ping. Now you can see I am able to ping. Yes or no? Let me
Yes, yes.
trace route 192.168.20.1. See. Oh, it will show you error. Okay, let me capture this link. Let me capture this link as well. I am capturing both link. So you can see this is my R3 to R2, R3 to R2, between R3 and R2, right here. Okay, and this one is R2 to R4. Okay, now let me ping. PC3. See, it's pinging. See, between R3 and R2 only ICMP requests are there. 1 2 3 4 5 requests, but in between R4 and R2 you can see ICMP reply are there only, right? So with this link I have captured reply on this link and I have captured request on this link, right? This one is reply between R2 to R4. So R2 is sending to R4. See, this one is reply and this one is request. So here is request, right? Source is 10.1 and destination is 20.1, right? Source MAC is, this is MAC address of which interface? Guys, PC1, wait, PC1 is sending a packet to 20.1, right? And I have captured this link, I have captured this data on this link. What will be the source MAC address of which router, which interface?
F01.
Yes, this interface, right?
Yes, this one.
And destination MAC address will be?
Well, all F, but all
No, why all F?
there is one router. The MAC of the router.
Destination MAC will be the MAC address of default gateway, because 20.0 is not directly connected with R3, right?
Yes.
So R3 will attach MAC address of default gateway. Who is default gateway? R2, fast Ethernet 0/1. So destination MAC will be MAC address of this interface, right?
Right.
So you can see this is the MAC address of R3 fast Ethernet 0/1, and this is destination MAC address is MAC address of router to fast Ethernet 0/1. Fine. So this is how you will configure a static routing, and you will perform load balancing as well, right? Your 50% traffic is going through this by using this path, and 50% traffic is passing by using this path, right? Okay, clear?
No.
How I will configure if I want that all traffic, my request and reply both will go via this link only. I want to use this link as a backup link only. What I will do? What I will do? Here I will run how many command? One command, right? That for this network, next hop will be R3. On R3 I will configure two route. First one is this one. For this one, exit interface will be fast Ethernet 0/0, and for this network, exit interface will be F0/1, right? Means for this network, default gateway will be R1, and for this network, default gateway will be R2, or you can say next hop will be R2, right? And on R3, on this router, you have to configure this network via R2, right? So this link will never used. Router will check their routing table to forward traffic in this network. They will find this exit interface, so router will forward to R3 only, right? But whenever this link will goes down, now you have to reconfigure R1 and R2 as well as R4, right? Okay, dear. Now suppose this is my private network, right? Now these user can access internet or not? Can this user access Google server? Now, no?
No.
Okay, here is ISP, and suppose this router is connected with ISP.
There is no DNS in the IP of the computer. Remote DNS.
Now they can communicate. Now R3 is connected with ISP. Suppose R3 is connected with ISP, and ISP have Google server. ISP have lot of server, right? So now this user can access server. Fine,
Yes, it can. Yes.
right? But suppose the IP address of this server is 8.8.8.8. Just suppose. Okay. So you have to perform routing on this router, right? Because whenever this machine will ping 8.8.8, right? How R1 will forward to R3? There should be one route in their routing table, right? For this network 8.8.8, for this network, what is exit interface? Yes or no? Yes or no? You have to configure static route for this network. In the same way on R3, right, on R2, on R4 as well, right? And there is million of website, there is million of server. Is it possible, guys, that I can configure each and every network in my private network? I can advertise this all network in my private network. Is it possible? No, right? It's not possible. How you will configure every IP address of every website on your router? Not possible, right? So what we can do? What we can do? DNS server. What DNS server will do? Okay. Okay, suppose here is my DNS server. What DNS server will do, dear? DNS server is resolve IP address to MAC address. Sorry, domain name into,
MAC address, right?
yes, into IP address. Domain name into okay. No, DNS can't do anything. We have default routing. Default routing. Guys, I have to tell to R3 that if you will not find any entry in the routing table for any network, you will forward that traffic towards ISP. If they will not find any entry, right? If you will receive some packet, in that packet, if destination MAC is 8.8.8.8, you will look their routing table. If they will not find any entry, right, what R3 will do? R3 will simply forward towards ISP. This is default routing. Default routing means last option router have, right, what to do if they will not find entry in their routing table. So if you will configure default route towards ISP, right, now R3 will not drop any traffic where they will find the network which are not present in their routing table. They will simply forward towards ISP every time. This is known as default route. And command to configure default route is IP route 0.0.0.0. 0.0.0.0 means any network. Any network. After that, subnet mask. Subnet mask will be 0.0.0.0 means any subnet mask. So when you will receive traffic for any network who have any subnet mask, right? If this router will don't know about any network, if router will not found any entry in their routing table, then if there will be default route configured, they will forward all traffic toward ISP. Now you have to tell exit interface. So exit interface will be, suppose this is my fast Ethernet 1/0. So exit interface will be F1/0, right? Okay. यस
सर कल का टॉपिक नहीं समझ में आया।
कल कौन सा हुआ था?
कल का
static routing.
वेस्ट राउटिंग।
तो फिर आपको पता ही नहीं है क्या हुआ था। ओके
Static routing ही किया है ये तो बोलो कि
है ना?
हेलो सर।
ओके बताइए ना, कर देंगे, समझा देंगे। हाँ
वैकेंसी है क्या?
हाँ
वैकेंसी एक्चुअली मैंने जॉब छोड़ा है इधर का।
ओके बात करते हैं फिर क्लास के बाद ना उसके लिए।
ठीक है सर, फोन करता हूँ।
बिल्कुल।
have we configured serial interface?
Yes, for connectivity from ISP in real time, definitely.
Maximum bandwidth for serial is 2 Mbps, right?
Yes. Here you will use in real environment optical fiber. So this is my ISP, right? There are lot of server. Suppose 8.8.8, 1.1.1.1, 2.2.2.2, right? 3.3.3.3. Okay. See. Now if I will ping 8.8.8.8, right, what R3 will do? R3 will simply drop that traffic, right?
Yes.
But
We need
if
to add a default route on.
yes, but if I will configure a default route towards R5, and whenever R3 will receive any traffic for 8.8.8, 1.1.1, 2.2.2, 3.3, or any IP address, what R3 will do? R3 will forward that traffic to R5. So first of all, guys, let me configure this loop back on R5. Configure terminal interface loopback 1. IP address is 8.8.8.8 and subnet mask is 255.255.255.255. Interface loopback 2 IP address is 1.1.1.1. 255.255.255.255. Exit interface serial 2/0, no shutdown. IP address is suppose 10.0.0.1.255.0.0.0. okay, let me configure R3. So on R3 interface serial 2/0, no shutdown. IP address is 10.0.0.2 255.0.0.0. IP is overlapping with okay, let me interface fast ethernet 0/1
Already configured.
shutdown. Exit interface fast ethernet 0/0 shutdown. Interface serial 2/0, no shutdown. IP address is 10.0.0.2 255.0.0.0. ping 8.8.8.8. Now see, R3 is dropping. Why?
There is no default route configured.
IP route. So IP route, you can see in the routing table there is no entry for 8 network, right? So what I will do, I will configure a default route. So see, IP route 0.0.0.0, subnet mask will be 0.0.0.0, and exit interface will be serial 2/0. See the routing table. So IP route. Now you can see gateway of last resort is 0.0.0.0 to network 0.0.0. Now router will, if router will not found any entry in their routing table, a specific entry, particular entry, right, then router will always use this route. This one is last resort. Okay, now if I will ping 8.8.8, tell me guys, will it ping or not?
I think yes.
Will it ping, Firaz? Firaz? Khalid? Will it ping? Will it ping? ICMP traffic will generate, right? Where source IP will be 10.2, destination IP will be 8.8.8, right? And there is default route. So definitely R3 will forward to R5. R5 will receive, they will check 8.8.8, right? Okay, so ISP will generate reply, right? In reply, source will be 10.1.1.1 and destination will be 10.1.1.2, right? So it will ping. Destination will be from ISP. When ISP will generate reply, what will be the source IP? Source IP will be 8.8.8. IP address of loopback 1, right? Because this traffic is going for loopback 1. See, yes, I am able to ping, right? Because of default route. So IP route. But if I will remove this entry, so IP route, no IP route 0.0.0.0, 0.0.0.0 and serial 2/0. Exit. Now you can see router is dropping traffic, right? Till now any dot? Anybody? No? Mahendra?
Yes, sir.
Yes, yes. एग्जैक्टली यही डिस्कस कर रहे थे कल भी,
हाँ
ऐसा है कुछ. ओके, so this is default route. On which router you need to configure default route? On edge router, right? On the router which is connected with ISP, right? But if you will configure default route on R3 only, then how R1 will forward to R3 when this user will ping 8.8.8? Still this user is not able to ping 8.8.8, right? Now I have to perform routing on R1 as well, right? Am I right? So actually when we will configure dynamic routing in this network, right, I will advertise this default route in that dynamic routing, then routing protocol will automatically share with their neighbor. then these all device will came to know about the default route which is connected to R3. So whenever R1 will receive any traffic, for that traffic, if they will not found any entry in their routing table, they will forward towards R3, because routing protocol, with the help of routing protocol, R3 itself will tell to R1 that default route is connected with me, right? Last resort is available for me, right? So last resort is ISP R5. Okay, so on default, on edge router, we will configure default route. Guys, tell me, by using default route, can this LAN user communicate with this LAN user with the help of default route? No. Why? See, if I will put one default route on R1, default route will be 0.0.0.0/0 and towards R3, right? I will configure this default route on R1. On R3 again I will configure 0.0.0.0/0 via R2. Now on R2 this network is directly connected, so my request will, but how this machine will, when this machine will generate reply, that time what will happen? That time there is no default route towards R3 or towards R4. So here I will configure one more default route, 0.0.0.0/0 towards R4, right? So when this machine router will receive a reply, they will check destination, right? They will not found entry in their routing table, they will match default route. So default route is towards R4, so definitely R2 will forward to R2, and on R4 I will configure one default gateway towards R1, right? And this user can communicate with this user. Right or wrong?
Right.
Absolutely right. We can. There is, but there is chance of,
This does not fulfill the purpose of using the default.
yes, there is chance of loop. There is chance of loop as well.
If we are doing the same work that we did in normal static
Yes,
with default way.
but you can make communication possible, right? So answer of this question is yes.
I said no just because you said we only configure default route
On edge router.
router is connected to ISP.
Because when you will configure default route, right, there is chance of loop. Okay, consider if I will configure one default route towards R3 on R1, 0.0.0.0 towards R3, and if I will configure one default route toward R2, 0.0.0.0, right, what will happen? If R1 will receive any traffic, right, if they will not found entry in their table, in their routing table, they will forward to R3. Again R3 will check their routing table, they will not found entry, so they will use default route. So default route is toward R1. Now again R1 will send to R3, R3 to R1, right? This traffic will move till 255 hop, right? So there is chance of loop. So that's the reason recommendation is only configured on edge router, on the router which is connected to ISP. Fine. So here we need to configure 0.0.0.0, and in this network I will not configure a static route after today, right? After today I will configure dynamic routing. From tomorrow I will configure dynamic routing, but hope static routing is clear to everyone, right? Now you know how to configure a static route and how a static route works. If this user will not communicate with this user, if you will try, you can do troubleshoot as well. right? You can ping your default gateway first, you can check the routing table of R1, you can check the show IP interface brief command, right? You can check the IP address, subnet mask, then you will ping your neighbor router from this router, right? Am I able to ping this IP address or not, right? And you can do troubleshoot, you can check what is the problem, right, in a static routing. Is it right or wrong? Yes or no? You can? You can or not? Can you do troubleshooting, dear, in a static route?
Yes.
Yes. So suppose if I
What can you do?
can you do troubleshoot if someone will configure a static route in a static routing, but two lanes LAN network are not able to communicate with each other? What is the reason? R1, R2. Here is 10 network, 10.0.0.1, 2, 3, 4, 5, and here is 20 network, 20.0.0.1, and here is suppose 1.1, here is 1.2. Fast Ethernet 0/0, fast Ethernet 0/0, fast Ethernet 0/1, and fast Ethernet 0/1. Okay. Suppose a network engineer configure one static route, that is network is 20.0.0.0/8 is directly connected with fast Ethernet 0/0. That means network engineer configured this route by using exit interface only, right? Okay, this is the routing table of R1. In the routing table of R1 there will be one more entry, 10.0.0.0/8 is directly connected with fast Ethernet 0/0. Am I right? In the same way, routing table of R2, if I talk about R2, there will be two network, and there will be one more network at this network, 1.1.1, fast Ethernet 0/0. Okay, there is one more network, that is
Will be written in front of it local.
1/32, fast Ethernet 0/0, right? Guys, now if in the routing table of R2, suppose there is 20 network, 10 network, and 1 network, okay, and for 10 network static routing is using exit interface, so this is fast Ethernet 0/0 directly connected with fast Ethernet 0/0. Now tell me, if this machine is not able to communicate with this machine, 10.1 is not able to communicate with 10.20.1, what will be the problem? What will be the problem?
Routing protocol.
Routing protocol?
Probably yes.
No need to perform routing, right? I had already configured a static routing. On R1 you can see 20 network is directly connected with fast Ethernet 0/0, right? And on R2 10 network is directly connected with fast Ethernet 0/0. So definitely this router will forward to R2, and R2 will forward in LAN, right? But why this machine is not able to this machine? If I am pinging, I am getting destination host unreachable or request timeout. Why?
Because 10.0.0.8 should be showing on fast Ethernet 0/1, not 0/0.
On fast Ethernet 0/1, what? Suppose IP address is 10.0.0.100, so it will become default gateway 10.0.0.100. Yes, now tell me.
And then on the other side also you need to configure.
Yes, other side also 20.100, and default gateway is 20.100. Okay, now what is the reason why this machine is not able to ping this machine?
Which is powered
Yes. Guys, this user will communicate with this user with the help of proxy ARP. Am I right? Proxy ARP. Right or wrong? Yes. What if someone will disable proxy ARP on this interface or on this interface? What will happen? ARP will never resolve. They will never communicate. First type of problem. So you need to check proxy ARP is enabled or not, right? How you will check? What is command? So IP interface fast Ethernet 0/0/0 suppose. See, proxy ARP is enabled. That's the reason why LAN user are able to communicate with other LAN user by using exit interface. But if someone will disable proxy ARP, right, LAN user will never communicate with other LAN user. Many times interviewer can ask this question, right? If I will configure a static router, because this is very easy question. Why LAN user is not able to communicate if everything is working fine? Sir, there is chance that proxy ARP is disabled on interface, right? We can check. Okay, what you will check if proxy ARP is enabled? What you will check if proxy ARP is enabled? Then what you will check? If this LAN user is not able to communicate with this user and proxy ARP is enabled, everything is working fine.
First of all, we will try to ping gateway IP
Yes,
0.100 if it is reachable or not.
yes,
And if it is reachable, then we will try to ping 1.2 IP to router 2.
will cool.
If that is reachable,
Yes, after that we will check IP reachability, hope to hope. We will have telnet access of all router on a single PC, so we don't need to move to configure anything on router 1 or router 2. I can configure both router by sitting on a single computer, right? We have telnet access. We can do troubleshoot online. Okay. But process is very simple, right? If you know how static routing is working, you can do troubleshoot. Fine. Is it?
How to disable proxy ARP?
Oh, okay. Let me show you. Go to interface first of all. Interface fast Ethernet 0/0. No IP proxy ARP. See this command. No IP proxy ARP. And how to enable IP proxy ARP? Okay, Khalid.
and by default it is enabled, right?
By default it is enabled. Okay, whenever you will go for lab exam, right, like CCI, you will see this type of problem in topology, right? It will, if this type of problem will take your time, you will never pass your lab exam. So actually manually they will disable the proxy ARP on interface, and they will do to find the problem, right? And within some time only, within 5 to 6 minutes, you have time 5 to 6 minutes only to do troubleshoot, right? So you should have knowledge about proxy ARP, right? Due to proxy ARP, communication can be stop if you are using a static routing using exit interface, in that case only. Okay, sir. Khalid, okay.
It's okay, it's okay.
Firaz, is it clear? Static routing?
Yes, yes.
Great. What about you?
Just need to be precise.
Troubleshoot?
No, it's okay, it's okay.
I will share some task to perform a static routing with you as well, right, in group. So try to configure that topology that I will share in group. Okay.
Okay, yes.
Okay.
After that you will never forget static routing. Okay, it will be very easy for you. Now we are going to start dynamic routing. So in dynamic routing we will run a process on router, and router will share routing information on the basis of that process. What information are required to build routing table? What information are required? First of all, remote network ID. To build routing table, what information are required? First thing is remote network ID. Second thing is remote subnet mask. And third thing is next hop IP address. Right? These three information are required to build routing table. Am I right? Am I right or not? Not.
Definitely.
Yes. So in a static routing, who is telling this information to router? Administrator is telling, right? In dynamic routing, who will tell this information to router? Routing protocol. Routing protocol that you will configure on this router, right? So first thing is these information are required to build a routing table. Okay, what will be the next hop for R1? Suppose here is one network 20.0.0.0 and here is one network 10.0.0.0, right? Guys, for 10 network from R2, who is next hop? Next hop is R1, right? For this network, next hop is R1. Who will tell to R2 that for this network next hop is R1? In a static routing, you will tell to R2 that exit interface will be this one or next hop IP address will be this one. In dynamic routing, who will tell to R2 that next hop is R1? R1 will tell to R2 that a network is connected with me, right? So for this network, next hop will be R1.
R1.
I will be the next hop for this network. R1 will tell to R2, right? And for 20 network, okay, from R1 next hop will be R2. Guys, what do you mean by hop? Hop means any device that can change layer 2 information, right? Always keep in mind, hop means the device which can change layer 2 information. Switch can't change layer 2 information. Am I right? Router can change layer 2 information. So router is a hop. Router is an hop. Firewall can also change layer 2 information. So firewall is a hop, right? And next hop means direction, right? What is direction to reach in this network for 20 network, right? What is the way to reach in 20 network from R1, right? What will be that? What will be the direction, right? So direction will be next hop. Am I right?
Yes, sir.
So for 20 network, R2 will become next hop for R1, right? Who will tell to R1? R2. Okay. And these are the information which required to build routing table. In a static routing, network engineer will provide this information, but in dynamic routing, router itself will give information to neighbor router. Okay, so if I talk about this topology, suppose here I am running network 192.168.10.0 and here 58.20.0. if I will run routing protocol, suppose RIP and RIP, right, what R1 will do? R1 will send information of this network to R2. This is my R1, this is my R2. What R2 will do? R2 will make entry in their routing table with next hop from where I am receiving this, right? How R2 will get to know about the next hop? From where I am receiving the update, the message, right? In message, source will be IP address of this interface. So this interface will become next hop IP address. Okay, guys, very important in routing. Next hop, everything is depend on next hop. Yes, fast Ethernet 0/0. Yes,
And when you are talking about dynamic, you are saying router 1 fast Ethernet 0/0.
router 1 fast Ethernet 0/0 is exit interface. No, I am saying that what dynamic routing will do, dynamic routing will send a message. R1 will send a message to R2. In that message, there will be information of this network, right? So this R2 will came to know that, okay, there is one network. But how many information are required? Network and subnet mask. So they have subnet mask also. Now next hop IP address, right? So how R2 will get next hop IP address? So router will check layer 3 information. At layer 3 source IP is IP address of this interface. Suppose 10.1, 10.2. So source IP is 10.1 and destination IP will be 10.2. Or destination IP will be broadcast or multicast, right? It will be unicast, it will be multicast, it can be broadcast, right? It will depend on the routing protocol. Okay, what will be the destination IP? Okay, so when R2 will receive this RIP message, right, they will check source from where I am receiving 10.1. So definitely whenever I will reach in this network, right, I will hand over to 10.1, right? So R2 is reachable to this network via 10.1. Clear? Clear, sir? See, types of dynamic routing. There are 4 types of dynamic routing. First one is distance vector routing protocol. After that, link state routing protocol. After that, advanced distance vector routing protocol. After that, path vector routing protocol, right? There are 4 types of routing protocol. Guys, distance vector routing protocol is RIP. RIP is an distance vector routing protocol. OSPF is an link state routing protocol, right? And EIGRP is an advanced distance vector routing protocol. Actually, EIGRP is combination of distance vector plus link state, right? And path vector routing protocol is BGP, Border Gateway Protocol. Okay. So first we will discuss properties of distance vector. What is the properties of distance vector? How distance vector works, right? Then we will discuss how link state protocol will work, right? Then we will discuss RIP and OSPF. Fine. First of all, we have discussed routing. So there are two types of routing. First one is static. Let me make this in bold here. First of all, we have discussed routing. Then we have discussed there are two types of routing, static and dynamic, right? Then we have discussed there are four types of dynamic routing. First one is distance vector, second one is link state, third one is advanced distance vector, and fourth one is path vector. Path vector. Example of distance vector routing protocol is RIP. Example of link state routing protocol is OSPF. Example of advanced distance vector routing protocol is EIGRP. And example of path vector routing protocol is BGP. Okay. Okay, sir. Clear? So see properties of distance vector routing protocol. Guys, what do you mean by distance? Distance means duri, and in networking distance means number of hop, right? R1, R2, R3, and here is one network, X network, right? So from R3, how many away this network is? So 2 hop away, 1 hop, 2 hop, 3 hop away, right? X network is 3 hop away from R3. So distance means number of hop. Fine. That means every distance vector routing protocol will calculate their best path on the basis of hop count. See here. Okay. R1, R2, R3 and R4. Suppose here is one network, X network, okay? X network. So when I will configure any dynamic routing protocol like RIP, so if I will configure RIP on this router, on this router, on this router and on this router, what R4 will do? R4 will share information of X network with their neighbor router, with R2 and with R4. Am I right? Now what R2 will do? R2 will again share the same information which R2 is receiving from R4. Now it's responsibility of R2 to share with their neighbor, right? So definitely R2 will share the network of X information about X network to R1, right? And in the same way R3 is also neighbor of R1, so R3 will also share the information of X network. Now R1 is receiving same network information from how many side? From how many side? From 2 side, right? How R1 will elect best path? Which path is best for me? So for that purpose, if you are using a distance vector routing protocol, that is RIP, distance vector routing protocol, that is RIP. So which path is best? For that they will check number of hop. So how many hope are away from this side?
2.
2 hope. And how many hope are away from this side? 2 hope,
2.
right? So number of hope from both sides is same, right? Now R1 will do load balancing. So every time what RIP will do, distance vector routing protocol will do, check the number of hope count from source to destination. Fine. So guys, okay, R1, R2 and R3. Okay, X network. Okay, now R1 will receive X information of X network from how many side? From 2 side, right? From this side and from this side. Which path will become best path?
This one, the shortest one.
This one, shortest path, right? So number of hope from this side is 1 and number of hope from this side is 2, right? So number of hope is metric. Metric is used to find best path. Least metric will always referred, right? So from which side R1 is calculating least metric? So in distance vector routing protocol, metric is just a hope count. Hope count. So from this side metric is 1. From this side metric is 2. So this path is best path, right? So best path selection will always depend on number of hope count. But guys, what is problem here? Suppose this is my network R1, R2, R3. Suppose here is network X. Okay, suppose the bandwidth of this link is 1 gigabit, right? 1 gigabit. And suppose the bandwidth of this interface is 5 kbps. Guys, which path is best for R2 to reach in X network? This path or this path? Which path is best?
GPS.
Theoretically, is the
Huh?
Will perfect the hope.
is the
Yes, according to RIP, this path is best path. But according to you, which path is best path?
Should be
This path is best path, right?
it's the fastest. Yeah.
Yes. So it's not sure that shortest path will perfect always, right? Long path can be good. Am I right? But RIP don't know about that thing. Yes. Yes, Khalid?
Yeah, depending of their speed.
Yes. It's depend.
But the read will not consider that speed.
Yes, they will not consider a speed. Suppose this is my house. This is my house, right? This is my main gate of my house, right? Here I am living, okay? And here is one main highway road, right? And we have 2 paths, we have 2 ways to reach highway from my home, right? This one is good path, best road with best bandwidth. Okay, suppose I can drive my car on this road at the speed of 80 km per hour. 80 km per hour. Okay, this is good road, but distance of this road is 2 km, and there is one more path, one more road. Suppose the distance of this link is only 1 km, right? But I can drive car at the speed of max to max 20 km per hour. which path is best for me? This one. But for RIP, this path is best path, because distance vector routing protocol will always prefer distance, only distance. They will never check the link characteristic, link bandwidth, right? This is a problem of distance vector.
For select path.
Your voice is breaking, dear. Can you speak again?
Only that is preferred to select path and incorporate next to hope count
Yes,
irrespective of the bandwidth of the link.
yes, exactly. This is problem of distance vector routing protocol, right? And RIP is an example of distance vector routing protocol, right? So definitely RIP will also use same thing, same characteristic, same property of distance vector. RIP will always calculate their best path on the basis of number of hop count, on the basis of distance. What parameter they will check to find best path is metric, right? Metric. So metric in distance vector routing protocol is, if someone will ask you what is metric in distance vector routing protocol, what will be your answer? Metric is number of
Hop count.
Hope count.
yes, number of hop count. So this is the first disadvantage of distance. If someone will ask you why we come up with EIGRP, right, you can consider this advantage, right, that if I will configure RIP, so RIP will always calculate their best path on the basis of distance, but that's not true. A longest path can be good, right? Okay. Now, so that means metric in distance vector routing protocol is number of hop count, and vector means direction, right? So distance vector routing protocol, you can say distance means hop, so definitely metric will be hop count, number of hop count, and vector means direction. In networking, vector means direction and direction means next hop, right? So distance vector routing protocol will always send periodic update to neighbor after a periodic interval of time. Oh my god, this is also a problem. See, in a distance vector routing protocol, problem number 2, there is one R1, there is one more router R2, both are connected. Suppose here I am running network 192.168.10.0 and here I am running 192.168.20.0. This full RIP routing protocol will send a message after every 30 seconds to R2. After every 30 seconds that there is one network 192.168.10.0. For this network, I will be your next hop. What is the logic of sending?
Keep like message.
Not keep alive message, right? Not keep alive message. R1 and R2 will not send keep alive message, any keep alive message of RIP, right? They will never check their neighbor is up or down. They will share a update after every 30 seconds. This is problem or not? If R1 will send one update to R2 that okay, I have one network 192.168.10.0, right? And whenever this network will goes down or a new network will come up, then only R1 should send update, right? Then only R1 should send update to R2, right? And when R2 will lose this network, then maybe R2 will ask to R1, then you need to send update. Why you are sending update after every 30 seconds? There is no logic. So this is second problem of RIP, distance vector routing protocol. So distance vector routing protocol will always send a periodic update, periodic, and you can change this time as well, right? If you want to configure 60 seconds, you can do that, right? So in distance vector routing protocol, update will be sent on a periodic interval of time. Okay, so by default time is 30 seconds in RIP, right? So if you will configure RIP on R1, R1 will send one RIP message after every 30 seconds. After every 30 seconds. Okay, properties of distance vector routing protocol. Now next property is distance vector routing protocol will always send update after periodic interval. Next property is how routing loop will avoid. Okay, how loop can be created? First of all, see, this is my R1, this is my R2. Suppose the IP address of this interface is A1, IP address of this interface is suppose A2, right? Here I am running network A, here I am running network B. Okay, fine. When I will configure distance vector routing protocol, R1 will send the information of network A to R2, right? To R2, what will be the next hop? Next hop will be A1, right? And number of hop will be 0, right? Number of hop will be 1. Number of hop count will be 1, right? For one A network, for R2 number of hop will be 1, right? Now R2 is receiving a network of A. R2 is receiving information of network A. Now it's responsibility of R2 to tell their neighbor, right? And neighbor is R1. So R2 will also send update with same network A, and next hop will be A2. Will R1 accept or not? Tell me, will R1 accept this message or not? Actually, when R1 will generate first update message, right, with information of network A, when R1 will generate at the first time, hop count will be 0. When that message will reach to R2, hop count will be 1. When R2 will send to R1, hop count will be 2. Now R1 will see their routing table. Okay, I have the same network with hop count 0 and I am receiving with hop count 2, so I will never accept it, right? So R1 will drop. But my question is, why R2 is sending same update to R1? How to stop this update message that R1 is sending to R2 is sending to R1? The same network information which R2 is receiving from R1. Why R2 is sending to R1 same information? Why? How to stop it? We have concept of split horizon. A split horizon. What a split horizon tells us? That if you will enable a split horizon on this interface, now this router will never forward the update which they will receive on this interface. They will never forward that update to this interface, to the same interface, right? Means when you will configure a split horizon and router will receive the information of network A on fast Ethernet 0/0. Now router 2 will never send the same update from fast Ethernet 0/0 because a split horizon is enabled. So a split horizon will not allow to router to forward same network information to the same interface on which they will receive. Okay, getting my point? Getting my point, what I am trying to say? A split horizon is a feature which is used to stop sending update on the interface where router receives same update, right? So on this interface on fast Ethernet 0/0 R2 is receiving the information of network A. So R2 will never send the network information of network A to this interface to fast Ethernet 0/0 if split horizon is enabled, and by default split horizon is enabled in RIP. So R2 will not send the same update to R1. If you will disable split horizon, right, then R1 will definitely drop that update, because in that update they will found HOPCON 2, right? So from one side this sorter is calculating matrix 0, and from one side, from here, this sorter is receiving same network with matrix 2. So which path is best? This path, directly connected path. So always keep in mind, for directly connected network matrix will be 0.
Yes.
For directly connected network matrix will be 0, right? For R2 to reach in a network matrix will be 1, right? When R2 will share the same information to R1, matrix will be 2. Now that's the reason why R2 will not accept that update, because R1 already generates same update with HOPCON with number of hop 0, right? And R1 is receiving same network with matrix 2. Why R1 will accept that update, right? So R1 will never accept this update. And if you want to stop this update on this interface, you need to configure a split horizon on this interface. Okay. Fine. This is a split horizon and root poisoning. Property of, see what is root poisoning. Guys, in this topology you can see there are 3 routers, R1, R2 and R3. IP address of this interface is A1, IP address of this interface is A2, right? Now see, R3 is receiving the information of network A. Where is network A? Here. This is my network A, right? Now R3 is receiving the information of network A from two sides, from this side as well as from this side, right? And when R3 will receive the information of network A, it's now become responsibility of R3 that you should share with R2, right? So R3 will share with R2 as well, right? So when R3 is receiving the information of network from two sides, but R3 will store via R1. Okay, R3 will store via R1 or via R2? Via R1. How R3 will store network A in their routing table? Via R1 or via R2? Via R1, because from this side matrix is list, right? Matrix is list. So from two side R3 will stored via, but if R3 will lose the connectivity via R1, if this link will goes down, after some time if this link will goes down, then R3 will send update to R2, right? They will ask to R2 that do you have reachability to a network, right? And mark matrix as infinity. If they will inform to R2, R3 will inform to R2 that I don't have connectivity with network A now, right? So in the update it will mark matrix as infinity. Means matrix is infinity for this network, for A network. Now definitely R2 will come to know that okay, R3 lost their connectivity. right? So what R2 will do? R2 will give the information of network A to R3. Am I right? So via R1, R3 will send update to R2, mark matrix as infinity. This is not breaking the rule. And guys, what is happening actually, if I have configured a split horizon here, a split horizon, right, and R2 is sending the same update, the information of network A to R3 on this interface, suppose fast Ethernet 0/0. Now the information of same network is sending on this interface by R3. Yes, now R3 is sending same information about network A to R2, but in the update matrix is infinity, right? Matrix is infinity. There is only single change, matrix is infinity, right? But there is information of same network. So this is breaking the rule or not? A split horizon. What a split horizon is telling? A split horizon is telling that you will never send the information of same network from this interface, right? If you are receiving this network on this interface. But guys, this is not breaking the rule because matrix is infinity. So this is not breaking the rule of a split horizon. It's working fine.
And when the connectivity window is done, it's the matrix to infinity.
Yes. Yes, they will mark matrix as infinity. If any router will receive an update where they will find matrix as infinity, that means that router will came to know that this router is asking to me, do you have connectivity to this network or not, right? If yes, you have, then please share with me also. Okay. But my concern is what is route poisoning. So route poisoning is whenever a router will lose their connectivity, their primary connectivity, right? They will ask to their neighbor router, right? From the same interface where they will receive, where they was received the update of network A. But this time matrix is infinity. So this is not breaking the rule. This is route poisoning. Okay. See, in this topology, now R1 is giving information of network A to R2 on fast Ethernet 0/0, right? R2 will never send the same information of network A on fast Ethernet 0/0. This is a split horizon. Am I right? This is a split horizon, that R1 will send the information of network A to R2 and R2 will never send the information of network A to this interface, fast Ethernet 0/0. This is a split horizon. But if R2 will send update on fast Ethernet 0/0 and mark matrix as infinity, this is route poisoning, right? Suppose if R2 will lose this network, right? So how R2 will ask to R1? They will put matrix as infinity in matrix field, and then they will send update to R1. Is it clear what is a split horizon and what is route poisoning? Guys, a split horizon is just a feature which will stop sending update, right? Same update on the same interface where router is receiving. And route poisoning is whenever router will lose to they will generate update and they will mark matrix as infinity, and then they will share with their or to their neighbor. This is not breaking the rule. This is route poisoning. Okay. Now property of link state routing protocol.
Listening is used just to wipe